Hi there, welcome to AK Online Academy. In today's lesson, we're going to continue looking at indices. Alright, so in the previous session, we looked at the first three laws of indices, that was multiplication, division, and double indices. In this session, we're going to look at three laws again, and these are going to be zero indices, negative indices, and fractional indices. Alright, so zero indices, the easiest way to remember this is this. Any value raised to the power of 0 is equal to 1, no matter how big that number is, okay? Even if you have 99 raised to the power of 0, it is simply equal to 1. So whenever you are solving exam questions, then you see something like this, just want to say any value raised to the power of 0 is a 1. Even 100,000 raised to the power of 0 simply gives you a 1. Now let us prove why this is so. So if you look at the first law of indices we're going to look at, we are borrowing the formula from division, okay? So this should now be familiar with you, okay? When we're dividing the same bases, we subtract the powers, right? Okay, so that is what we have up there. That is the expression used to divide indices that have the same base. Okay, we now come to this example here. Let's say we have this question, a to the power 3 divided by a to the power 3. Since when we are dividing, we subtract the powers, meaning we're going to say 3 minus 3. What does it give us? It gives us a 0. Okay, so meaning this divided by this is going to give us a to the power of 0. The same question, if we solve it using the algebraic fraction method, we're going to say a to the power 3 divided by a to the power 3. Okay, and then you remember in that session when where we're looking at algebraic fractions, you'd expand the values and then you start reducing, right? You start cancelling out the values. So a to the power 3 simply means this a is being multiplied by itself 3 times. So these are the a's we have up there. Same applies here. These are the a's we have up there, down there. So now we start cancelling. This a cancels that a, this one cancels that one, this one cancels that one. What we have up there, because everything has been cancelled, we're going to remain with the 1 up there, and down here we're going to remain with a 1, meaning it's going to be 1 divided by a 1, giving you a what? A 1. Okay? Therefore, a to the power 0 is the same as what we have found here. Okay? This same solution gave us this one, and this same solution, this same question, gave us this one. Therefore, any value raised to the power of 0 is equal to 1. Don't even try to overthink it or anything, just know that any value raised to the power of 0 is equal to a 1. Similarly, when we come to negative indices, we're also going to use the same formula for dividing indices that have the same base. Okay, so let's say we have a to the power 3. So now remember in the previous sessions I said we would be subtracting the smaller powers from the bigger powers so that we do not end up with negative values, right? Okay, so now this case we're just going to go direct because we're trying to deal with what? Negative indices. Like I mentioned, I said we're going to look at negative indices at a later stage. This is the stage. Alright, so now let's say you're dividing a to the power 3 divided by a to the power 4. It simply means since the bases are the same, we're going to subtract this power. So meaning it's going to be 3 minus the 4. Okay, 3 minus 4 gives you a negative 1 there as the power. Okay, the same question, we solve it using the algebraic method. Algebraic fraction method, meaning it's going to be a to the power 3 divided by a to the power 4. Up here, we have 3 a's being multiplied by themselves. Down here, 4 a's. And then when we start cancelling, that a cancels that one cancels that one, that one cancels that one. Up here, what do you remain with? We remain with a 1. Down here, all the a's have been cancelled except for 1. So meaning, the final answer is just going to be 1 over a. Therefore, a to the power negative 1 is the same as 1 over a. Alright? So this is going to be very this will come in handy when you start dealing with calculus. There are times they give you to say find the derivative of maybe 4 over x squared. Okay, you need to revert it as a negative power, or at the end when you're done solving, let's say you have 4x to the power negative 2. You need to write it as that value there. So this is why this is going to come handy. So any value raised to the power of a negative power, you simply put a 1 on top, then you drop the base, and then the power goes down to the base. So for example, 4x, let me use just one variable so that we do not look at something a little complex. So let's say you have x to the power negative 2. What we're just going to do here is this negative, we're just going to write 1 over for the negative, and then we get the base, we bring it down here, and then the power drops down to the base. This negative index has been expressed as a positive index. If you have 2 to the power negative 3, it's just going to be 1 over, in other words, this guy here is the one giving us what we have there. And then the base comes down here, and then the power drops to the base. And then we can simplify the base further. 2 cubed simply gives us 8, and that would be our final answer. So that's how you deal with negative indices. That's why you convert them from negative to positive and vice versa. If we converted this back to a negative index, meaning it's going to be 8 to the power negative 1. Alright? So that is that. Let us now look at these questions so that this can sink in. Let me just create some space over here. Alright, so the first example, we're not yet done. Let us look at fractional indices before we get to the examples. Alright, so we're done on negative indices. So now when we come down to fractional indices, we have 8 to the power m over n. So in this case, you notice to say the power is a fraction. How do you deal with a question that has the power as a fraction? Okay, what you simply do is you come up with this arrangement where you have a root, and then the base goes inside the root, okay, and then the bottom value, the n, the denominator, the power is a fraction, the denominator is the root, so it comes and sits right here, okay, and then the numerator is the power, okay, so you put it right outside the bracket. For example, before we get to that one, so that at least this can also sink in. Let's say you have 27 to the power 3 over 2. What you're going to do is you're going to introduce this root right? And then we said the bottom number is a root, so it comes here. And then this is your base, it goes inside the root, and then you add brackets, and then the top number, which is the numerator, is the power. It's one that comes outside. So that's how we're going to write it like that. Let's say you have 16 raised to the power of 1 over 2. What you're going to do is you're going to come up with a root. The bottom number we said is a root, so it comes and sits there. The 16 is the base. Then you put brackets, and then the power, which is a 1, goes there. Okay, so that is how you interpret this kind of question. Sometimes they'll give it to you like this, sometimes they'll bring it to you already changed to that format. Otherwise, it means one and the same thing. Okay, we now go to the examples. Let us now see how we answer these questions. So the first one says, actually this one was written wrongly. This was supposed to be 1 right here, like that. So this is question 1, and then we have A there. Then we have question 2, which is evaluate. So question 1 said, rewrite each value as a positive index. So what we have down here are all negative indices. Okay, we have 5 to the power negative 2, 2 to the power negative 3, 4x raised to the power of negative 2, 2y raised to the power of negative 3. So we'll start with 5 to the power negative 2. So that is question 1a. 5 to the power negative 2, we said this negative we simply say 1 over, then the base comes down here, and then the power drops to the base. After that, we can simplify this one, right? So I'm going to say 1 over, what is 5 squared? 5 squared, excuse me, like we mentioned in the previous session, does not mean 5 times 2. It simply means 5 times 5, giving us 25. And so this is our positive index. We come to B. B is 2 to the power negative 3. Okay, so that negative will simply give us 1 over. The base comes down here, and then the power drops to the base. Okay, 1 to the power 3 does not mean 2 times 3. It simply means 2 times 2 times 2, which gives us 8. So that would be our final answer there, as simple as that. We now come to C, which is a bit different. Negative 2, is it? Yeah. So here you notice to say this negative power belongs to x. It does not belong to 4. 4 is actually raised to the power of 1 here. So meaning what we're going to do, the simplest thing we can do here is we separate these two. What operation is going on between 4 and x? It is multiplication. So we're going to say 4 times x to the power negative 2. And then we convert this one to a positive index, meaning it's going to be 4 times, we say that's negative, simply gives us 1 over, and then the base, which is the x, goes down there, and then the power drops down to the base. Okay, so meaning our final answer is just going to be over 1 there, 4 times 1, 4 over 1 times x squared is x squared, and this will be our final answer. Okay, so you notice, like I mentioned, this will come in handy when we start dealing with calculus. So you find that mostly integration actually. When you're done integrating, you find the final answer that you have a negative index that looks like this. You need to convert it to a positive index, so you have to bring it to that. And we are done. We now go to D. D, same thing as this one. We have 2y to the power negative 3. Okay, so we know to say this y, this negative power belongs to y. So meaning we try to separate them. Okay, so that we have something like this. And then we're going to say 2 times, to convert this to a positive power, we're going to say 1 over y to the power 3. Okay, the negative there gives us 1 over, then the base goes down, the power drops to the base, meaning it's going to give us 2 times 1 gives us a 2 over, say over 1 there, 1 times y cubed will give us y cubed, and that will be our final answer, and we are done. We go to question 2, which says evaluate 8 to the power 2 over 3. B, we have this expression right there. C, we have 16 to the power 3 over 2, and D, we have that expression there. So 8 to the power 3, how do we solve such a question? 8 to the power 2 over 3. We said you need to come up with a root, right? Like that. And then the bottom number is a root, so it comes and sits there. The 8 there is a base, so it goes inside the root, and then you add the brackets, and then the top number, which is the power, goes outside the bracket. So now, how do you simplify this? Okay, how do you evaluate this? In other words, all we are asking for is the cube root of 8. In a simplified version, you're looking for a number which you can multiply this much times to give you 8. What number can you multiply by itself 3 times to give you 8? That number is 2, okay? Because 2 times 2 is 4, times 2 gives you 8. Like this, 2 times 2 times 2. 2 times 2 there gives us a 4. 4 times this 2 gives us 8. So meaning the cube root of 8 is going to be what? 2. So this 2 replaces everything inside the brackets, and then this power drops down to that value. And then 2 squared will give us what? 4 as our final answer. And you're done. Okay? We go to the next one, which is B. So this is A. And B, we have 9. Let me just write it properly. So we have a root there, we have a 2 there, we have a 9 inside, raised to the power of 1. Okay? This one simply means what is the square root of 9? Okay? Or what number can we multiply twice by itself to give us a 9? Okay? You start trying. If you don't know the number, you start trying from the smallest. How many times should we multiply this number by itself? Twice, right? So we're going to start 2 times 2. What does it give you? 4. That is not the number. You go to the next number, which is 3. 3 times 3. What does it give you? 9. So meaning the number you can multiply by itself twice to give you a 9 is a what? A 3. Meaning this everything inside the brackets will be replaced by that actual number. So I'm just going to have 3 to the power 1. But we said when the power of the value is 1, you don't write it. So the final answer is just going to be 3 there instead of saying 3 to the power of 1. And you're done. We go to the next one. 16, that is C, 16 to the power 3 over 2. Okay, so we come up with the root, the bottom number sits there, the base goes inside the root, we close, the top number is the power, it goes outside. Okay, what number can you multiply by itself? 2 times to give us 16. We tried 2, it gave us 4, 3 gave us 9. So we go to the next number, which is 4. 4 times 4 is the one that gives us 16. Therefore, the square root of 16 is 4. Then the power comes there. Or in other words, the number that you can multiply by itself 2 times to give us 16 is what? Is a 4. And then at this point, we are going to say, what is 4 cubed? Okay? 4 cubed simply means 4 times 4 giving us 16. 16 times 4, 6 times 4 there will give us 24. Remember 2. 4 times 1 gives us a 4 plus that 2, 64. Therefore, 4 cubed gives us 64 as our final answer. We now go to the last one, the second last one. There's one that's a very nice one that I forgot. Okay, I need to give you an example of that version as well. So I'll add E. So D, we have a 3 there. Inside the brackets, we have a 125. We close, and then when we have the power is a 2. So here we're looking for the cube root of 125, or basically a number we can multiply by itself 3 times to give us 125. The number that we can multiply by itself 3 times to give us, if we multiply 4 by itself 3 times, it gave us 64, right? So we can't try, we've already tried 4. Okay? 3 cubed gives us 27. 3 times 3 is 9 times 3, 27. 2 cubed gives us 8. Okay? 4 cubed gives us 64. So we go to the next number to try, which is 5. What is 5 times 5 times 5? Let's see. Okay? 5 times 5 times 5. This one here gives us what? 25. 25 times this remaining 5. We're going to say 5 times 5 is 25. Remember 2. 5 times 2 is 10 plus that 2 gives us a 12. Therefore, we have our answer, which is 125. So the number that you can multiply by itself 3 times to give you 125 is 5. Okay? Or the cube root of 125 is simply a 5. And then the power goes to that number. 5 squared gives us what? 25. And you are done. Now let me add E. Okay? Very interesting question. There are times they will bring you double fractions and people get confused. I think it also came in 2025 exam paper. I've forgotten. I may be wrong. Yeah. But this question is common. Sometimes people get confused. In fact, we've not had any question with zero indices on the work examples. So let's have something like this. Let's say we have in brackets, we have 8 to the power 8 over 9, and then the power is 3 over 2 plus, then here we have let's say 9 over 8. Okay, the power 0, and they're saying evaluate. Okay, let's call this one 3. So this will be A, and then let's say we have B here. For example's sake, let us use, okay, let's say what number can we use? Okay, let's use 9 over 16 to the power negative 2. Okay, yeah, this one as well. Okay, let me use smaller values for this one. Let me put a 2 there and a 3 there. Yeah, okay. So for this one, 8 over 9 to the power 3 over 2. So there's a fraction inside, and there's also a fraction here. So we have how many rows here? We have 2 rows here. We have double indices and fractional indices. Remember in the previous example I gave you a question where we had double indices, right? A fraction and then there's a power outside. Then I mentioned to say this value up there has its own power, this one has its own power also. When you have a power outside, when you have double indices, the power outside multiplies all the powers inside, right? So initially it's going to be 1 times 3 over 2, 1 times 3 over 2, meaning we're going to have 8 to the power 3 over 2, because 1 times this is this, over 1 times that will give us 9 to the power 3 over 2, which then is then we say plus. Okay, for this one, same thing. Okay, there's a 1 here, right? There's also a 1 here. 1 times 0 there will give us 9 to the power 0, because 1 times 0 is 0, over 1 times 0 there will give us a 0. So I'm trying to simplify things right now, and I'm doing all unnecessary steps for those that already know this question. Okay, and then at this point we can do this. We can say up here. So what's our root? Our root is 2. Okay, our base is what? 8. And then you close the bracket like that. And then what's our power? Our power is 3. And then over down here we have another root. What's the root there? It's a 2, the base, a 9. We close the brackets. What's the power? A 3. And then we say plus. Here what are we going to have? Any value raised to the power of 0 is what? 1. So we're going to have 1 over 1. 9 to the power 0 is 1. 8 to the power 0 is a 1. And then here, what number can you multiply by itself twice to give you 8? There is no number. So let me change the top value. Let me put a 4. Okay, sorry about that. Let me put a 4 here, so that the powers can match. Yeah. Hey, I have to change it here. So this was made up. I just want you to get the concept. Okay, what's the number that we can multiply by itself? I'm trying to avoid square root, cube root, because sometimes you find you have a bigger value, and then people may get confused. That's why I'm trying to introduce it as simply as possible by saying, what number can you multiply with? Okay, what number can you multiply by itself 2 times to give you a 4? That is a 2, right? So meaning up here in the brackets, we're going to replace everything by what? Or with a 2. Okay, everything here, what number can you multiply by itself twice to give you a 9? It is a 3. So meaning everything in the brackets has been replaced by a 3, right? Okay, so now here the power drops to this one and that one there. Okay, so meaning plus again. Plus 1 divided by 1 there will give us a 1. What is 2 cubed? 2 cubed gives us 8. Alright, let me erase the bottom part. We need more space. So this one is a step-by-step solution, but I'll show you a shortcut. Okay, so let us bring what we have this side. 2 cubed, 3 cubed plus 1. Okay, 2 cubed gives us 8. 3 cubed gives us 27, and then we say plus 1 over 1, which is going to give us 27 as a common factor, common denominator. 27 by 27 is 1. 1 times 8 is 8. Bring down the sign. 27 divided by 1 is 27. 27 times 1 gives us 27, meaning we're going to have 8 plus 27, that should give us 35. Okay, if I'm not mistaken, yeah, 35 over 27. Is there a number that can go into both of these? I doubt that. No, there's no number. So that would be our final answer. Now, here's a shortcut. Okay, that was a step by step so that people know exactly what is supposed to happen. So now, just right here, where we have 4 over 9 in brackets, just the way the question is, all you do is you do this. Introduce a big root. And then inside the brackets, you're going to have 4 over 9. Since the powers you're going to be using are the same. Like you notice, the powers there were the same. So then there's no need for you to put each one of them in individual brackets. And then that power will come and sit there. And then that root will come and sit there. And then the power goes there. We close Then here you can simply say, because we know everything here is going to convert to a 1, you can simply say plus 1. Any value raised to the power of 0 is a 1. Okay, so there you can simply say plus 1. And then we're going to solve this question this way. Okay, what number can you multiply by itself twice to give us a 4? It is a 2. Over, what number can you multiply by itself twice to give us a 9? It is a 3. Okay, you add brackets, and then you can say the power 3 plus 1. What is 2 cubed? 2 cubed gives us 8. Over, what is 3 cubed? 27. Plus a 1 over a 1. And then we can continue solving it that way. We have the common denominator as 27. Okay, there we have a 1 times 8. 8, bring down that sign. This divided by that is 27 times 1. 27 giving us 35 over 27, and we are done. So that will be our final answer using the shortcut method. We now come to this guy. Very, very important. Okay, don't miss this one. Okay, we have 2 over 3 raised to the power of negative 2. Okay, I've already shown you a longer method. I don't want to show you another longer method. Okay, I don't want to lose anyone. So I'll give you a shortcut, right? Whenever you have a negative power, and inside the brackets you have a fraction, this is what you do. To convert this negative power to a positive, simply swap the values inside the bracket. So here we have 2 over 3, we're going to change to 3 over 2, and then our power becomes a positive. Alright? If you're interested to find out why, you can go ahead and research. Or you can inbox me, I'm going to show you a longer solution. But I just don't want to complicate things, because as I'm explaining this, some people may forget what I've explained here. So here is a shortcut. Whenever you have a negative power here, okay, to convert it to a positive power, you simply swap or flip the values inside. The numerator becomes, the denominator becomes the numerator becomes the denominator. And you are done, you've changed it to a positive. At this point, you can simply say, what is 3 squared? 3 squared is 9. Over, what is 2 squared? Gives us a 4. And you are done. As simple as that. So that is pretty much it for today's session. It has been a bit longer than anticipated. So make sure you go through everything carefully, understanding every point. Okay, because we are actually nearly done with indices. We're just remaining with 2 more laws. That is equations that involve indices. We have, that's what we'll look at in the next session. Let me not go into details about that. So otherwise, thank you for watching. Remember to solve, and solve. Okay, remember in the previous test I gave you, most of you didn't manage to finish. Okay, so you need to work on your time management. The easiest way you can get better at solving, okay, and utilizing the time given is by solving frequently. Okay, your speed will increase. You'll be able to solve without making many mistakes. The more you do it, the fewer the mistakes you'll be making as you solve. So make sure you solve, and solve. Mathematics is a practical subject. Don't just end up watching videos, okay, and submitting assignments. You need to create time for solving. Alright, so otherwise that is that. Thank you for watching, and I'll see you in the next one.